Unitelma Sapienza, coordinator of SASTRAC project, for the opening of the day. Please, Gülsa, the floor is yours, and enjoy the workshop, everyone.
Okay, thank you, Valentina. And also from my side, good morning to everyone, and thank you for joining us today, the series of our design workshops. So I will just share my screen quickly. Okay, I assume you see it in the presentation mode right now. Okay.
Yes.
So thank you. So this is the second workshop that we are conducting in the design conference series. Today we will be discussing about the construction sector. And just a quick overview of our objectives of these workshops. So our objectives are threefold. First, we want to present an overview of the selected SUSTRAC value chains in the construction sector. We will provide the process description, market information, and relevant policy instruments as a starting point for debate. And then we will hear from our invited speakers specifically about their case studies, and we will hear from their side, their perspectives, their good practices and challenges and or barriers they are facing in the transition towards a more circular and bio-based economy. And finally, we will discuss the three dimensions, which are policy, environmental and societal and economic dimensions. And building on all these discussions, we will provide recommendations for the transition towards circular bio-based economy in the construction sector. And the outcomes that we are expecting from these workshops are firstly to provide actionable knowledge in terms of inspirational good practices that we will hear from our invited speakers and their challenges, barriers, and recommendations in the sector, and to collect additional information to our ongoing SUSTRAC research. It can be in terms of identifying relevant indicators or highlighting the data availability or data gaps. And finally, to co-create tailored policy recommendations to pave the way for future policy developments at different levels, such as regional, national, or European. And we have quite a full agenda today. This is the opening of and the overview of SUSTRAC project will come in a second. And then we will continue with our case studies, starting with cross-laminated timber. First, we will provide our presentation from SUSTRAC's point of view, and then we will hear from our invited experts, their perspectives, their contributions. Then there will be a short Q&A session. And the same structure will be followed for the second case study, which is biochar as an additive in concrete. And then the third one, hemp insulation. In all these case study slots, we will first provide our perspective and hear back from the invited speakers. And then as the last part, we will use the Mira board as an interactive tool to discuss the three dimensions, which will already be mentioned during the presentations. And we will open the discussion for all participants to contribute with their insights, with their suggestions, recommendations, and any kind of questions and concerns that they have. And finally, we will conclude our meeting in less than 2 hours, let's say. And now, very quick glance at our project for the ones who are hearing from us for the first time. So SUSTRAC reads as supporting the identification of policy priorities and recommendations for designing a sustainable track towards circular bio-based systems. We started in November 2022, and this is going to be a 3-year project, which is a coordination and support action. This is also why we are constructing a stronger relationship with our stakeholders. So this is also why we need your inputs, your insights to tailor our strategies to move on with our research. And very quick keywords from our abstract. So we start with the need for this transition from linear fossil-based systems to circular and bio-based models, underlining the opportunities to reconcile sustainable long-term growth with environmental protection. However, a critical assessment of different impacts of the linear economy and the improvement potential associated with circular systems is needed to derive and to identify policy priorities. So building on these needs, SUSTRAC aims at supporting policymakers to develop sustainable pathways and in an effort to replace fossil and carbon intensive systems with more sustainable, circular and bio-based ones. And of course, at the same time, contributing to achieving the European Green Deal's objectives. And at this moment, I also would like to encourage you to visit our website, to sign into our social media channels, which we are using very actively in order to communicate our upcoming events and also the findings from our project. So please feel free to join us. And the objectives of our project, the main objectives and specific objectives, we have two main objectives in mind, starting with providing knowledge and tools for assessing the impacts. And of course, building on this knowledge and tools to identify policy actions at different levels, such as European, local, or cross-territorial. And we are using 5 specific objectives as stepping stones in order to reach the main objectives. The first one is to identify, assess, and prioritize the limits and the barriers related to linear and circular systems, which we already finalized during the first half of our project. And now we are in the phase of developing knowledge and tool for monitoring and assessing the impacts. We are going to assess the impacts with a case study approach. So these workshops also belong to this specific objective. And finally, building on the information and knowledge gathered, we will create, simulate, and interpret a variety of scenarios using system dynamic modeling to interpret the results of the transition to a sustainable pathway. And we will use all this information to derive policy priorities, define corresponding policy actions, and to provide recommendations. And this is a quick glance of our first findings. So we started with the identification of barriers in the construction sector, specifically in this case. And we looked at the problem in different clusters, being cultural, economic, environmental, governance, and structural and technical barriers. So just to name a couple of them, for example, like an environmental barrier, we identified lack of harmonized methods for environmental, climate, and sustainability impact assessment stand out. And for example, for structural barrier, it was social and technical lock-ins in the current linear systems. And as you can see, there are many barriers in this transition, and it also reflects the complexity of the problem that we are dealing with. And with this, I would like to just pass the floor back to Valentina to hear from our invited speakers. And thank you again for your attention in our event.
Thanks, Gulsa, for the great overview. So before moving into our very intense agenda, we would like to break the ice a bit with all the participants. So Selena are gonna sharing the screen. So we are asking to you, we are still waiting for the screen. Here you can scan the QR code with your cell phone, or you can go directly from your laptop, your PC to menti.com, entering this code. You will see that after entering, you will start visualizing a question. So we are gonna ask, what kind of stakeholder category do you represent? So we are very curious to know to which of these categories you are part of and you represent. So don't be shy. If you have issues in entering, I can also copy and paste in the chat the link to access directly to the Menti. Okay, I see we have researchers, we have SMEs and startups, but I'm sure we have also industries here, so we are waiting for people to enter. I don't know if Stella, you want to just go back and share also the QR code if people are still entering. Okay. So more responses are coming. So I see a good balance. So we have researchers, we have big industries, but also SMEs and startups. We have others. We are missing a bit policymakers, as expected. And
But
I
we
think
remember
we,
you that there will be the policy conference at the end of those 4 workshops. So here we don't expect to have those people, while they will be present in the conference in which we will be invited, that will take place in September, in which we will aggregate all the results, and then we will present them to the policymakers.
good. So I think we broke the ice at least. So I can leave the floor to our experts from Ghent University, to start with the first case study, so cross-laminated timber, as anticipated by Gülsa. So Toby, please, the floor is yours.
Yes, good morning. I will present you, I'll share my screen so that you guys can see the presentation. All right, everything should be good, I hope. So maybe quickly, so together with my colleague, Professor Joris van Akker, we at the Ghent University are responsible for 2 of the case studies within the construction sector, one of them being cross-laminated timber and the other hemp insulation. But we'll first start off with cross-laminated timber. So maybe a quick and brief description of the case study and the value chain. So maybe let's start with the feedstock, which in this case is wood, or in terms of cross-laminated timber, it is almost exclusively softwood, at least here in Europe. Maybe very quickly, what is CLT? It's a pre-manufactured, prefabricated wood panel that can be used as an alternative construction material for concrete and steel. Some of its advantages are sustainability, low weight, and a very fast construction speed compared to steel and concrete. The whole value chain you can see in the picture, and it starts off with, of course, the feedstock, which is wood, which then is turned into timber. Some of the building blocks of CLT are the dry timber, because of course it does need to be dried, and adhesives. So most CLT today is still produced with adhesives. And these are the building blocks, let's say, for the final product, which consists of very quickly the manufacturing steps, which is like sawing and turning the timber into the desired length, gets pressed into a panel, and then it gets made to order, let's say, or the CNC machining. So an advantage of CLT is that it can be made to order, so that when it leaves the factory or leaves the plant, it can be shipped to a construction site and installed very fast. And then at the end of the cycle, there is the potential of reusing the material. So of course, it's in a very early stage, let's say, or mechanical recycling, such as either biomass or maybe feedstock for other engineered wood products. Then maybe also a quick overview of the baseline and the market. So yeah, CLT is made up from like lumber, and it gets glued together in layers which are perpendicular to each other. Application can be walls, floors, roofs, and stairs. So it's a very versatile material. It can also be used in both residential, let's say commercial, institutional. It also has the advantage that it can be used for high-rise construction. So it allows from a wood high-rise construction. A very quick view of the European market. So at the moment, or in 2023, the production volume was about 1.7 million cubic meters per year. This production is expected to grow to about 2.3. Now, let's take at Europe. So Europe is still the largest global manufacturer of CLT, with the main manufacturers still being the DACH region, so Germany, Austria, and Switzerland. But more and more production in other countries, such as Italy, the Czech Republic, but also, let's say, the Baltic states or Scandinavia, Finland, Portugal, and Italy is starting, the production is starting to become even more spread both globally and within Europe. Then we also have mapped all of the stakeholders who were involved within the cross-laminated timber value chain. Let's maybe start first with the bioeconomy supply chain itself, which of course starts with the woods or forests, which needs to be managed and harvested sustainably. Then the building blocks, which are of course the lumber and as well the adhesives that are need to be used for the actual manufacturing of cross-laminated timber. Then the next step is of course the installation, but also maybe the design and the construction of buildings with CLT. And then at the end of the life or the end of this of the process of CLT, there is the potential to reuse it or to recycle it or bring it back within the supply chain. And then on the government levels, there's both policymakers, but of course also partnerships that focus on sustainable construction, but also maybe even on a larger scale, like supranational organizations, such as the UN with their sustainable development goals. Then, of course, there's also inputs from the academic world, so research into construction, bio-based construction materials and timber construction materials are an important input for the cross-laminated timber value chain. Then on an industry level, also financing, so financing of timber-based products or construction projects, as well as the insurance are an important factor in the value chain, as well as, of course, the businesses and the marketing of the product, so getting the product to the customers. Then on a society level, of course, people are still the main focus, or people living in houses and customers using buildings are still have a big impact as well as sort of, let's say, the mindset and opinion on bio-based building, which still is also at the moment a quite big input or a big important factor. And some policies irrelevant. I think most of our case studies will have the European Green Deal as one of the relevant case studies, but of course, in our mission to reduce emissions and be net neutral by 2025, sustainable building is quite important, and CLT can be a building block for this. Also, the new EU Forest Strategy for 2030, which of course also has a focus on extending forests, but also has a factor in our CLT value chain, as that of course forests are the feedstock or the one of the important blocks within our value chain that need to provide the materials so that we can use wood as a sustainable building materials. Then the construction product regulations. So regulations, of course, CLT and every bio-based material needs to meet standards. Of course, here there's also quite, this can also help push with the use of sustainable building products. Circular economy plan also has a focus on bringing or increasing the use of sustainable products, including in the construction industry. And then LEED, for example, is an example of a green building certification program, which can also sort of help push and help with the standardization of green buildings. Then also we have identified some very important sustainability indicators, both on an environmental, economic, and social level. Let's first start maybe with environmental ones. So the change in wood and wood products or forest products and wood consumption, of course, are two rather important indicators when it comes to CLT, as well as the post-consuming recycling rate. While CLT does have a quite long life rate, what we do at the end of it can be quite important into the sustainability of CLT as a material. Then the life cycle greenhouse gas emissions and the rate of that we can reduce greenhouse gas emissions are also two, let's say, relevant and important factors which can affect CLT, or where CLT can be impactful. And carbon stock or storing carbon is also one of the big selling points of CLT. And this, together with climate regulation potential and forced carbon emissions, can be one of these important factors which helps not only just CLT but bio-based materials. Then on an economic level, the total raw material productivity. So here once again is a link with forests, but also how much wood we can use and we can produce. It's linked, of course, to forests. Also within the value chain, there are of course some let's say not very. I don't necessarily like the use waste, but maybe like let's say buy streams from biomass, which can be optimally used and which can both have an economic but also environmental factor. And then of course the recycling rate, or keeping the products as long in our circular economy, is quite important. And on a social level, certifications or labels with a focus on sustainable building can also be an important indicator. So this was a very quick introduction to CLT. And with this, I would like to now invite our speakers, and which is first is going to be Nathalie Lebrun from Stabilam. So the floor is yours, Nathalie.
Good morning. Good morning, everyone. I shall share my screen first. So do you see my screen?
Yes, we see it, not in presentation mode yet.
Right. You got it?
Yes.
Yes, perfect.
Right. Thank you. So good morning, everyone. My name is Nathalie Lebrun, and I'm working in the company Stabilam, which is a company producer of CLT based in Belgium. We are a quite small company with 102 workers, and we are both manufacturer and contractor making small to large buildings in wood. So about the different barriers we are facing regarding the policy dimension, let's first talk about the legislation. And the first barrier we are facing is about fire safety for buildings, because the fire safety legislation is studied for the traditional materials like concrete, bricks, and is based upon fire resistance. While regarding to reaction to fire of building materials, wood is far better. It has excellent results for evacuating people. The second barrier is about design. If you want to promote bio-based materials, you have to know that bio-based design is disadvantaged. In fact, if the design of bio-based material has to be done with the same parameters as geo-based or petrol-based materials, it is possible, but it will always be more expensive. So as prices remain the choice factor, then the bio-based building sector is always penalized in its development because design is made upon concrete parameters. So then we propose two solutions. The first one is to modify the norms to promote the concept of evacuating occupants and the reaction to fire instead of the fire resistance of materials. And then also to use sprinkler system in order to protect both buildings and their occupants. In Norway and Sweden, they have modified the legislation and they got a large increase of wood buildings with high and large buildings. So regarding the environmental dimensions, we point out two main barriers. The first one regards the assessing the impacts and the norms relative to LCAs and EPDs. And regarding that, we have 3 points, sorry. So the first one is that there's no real uniformity. EPDs are based on the identical norm, but each country has its own specifications. And for example, EPDs in Belgium or France, they cannot be used in one other country. And that is really a problem for us because the bio-based product producers are mainly SMEs, and it's not possible to multiply the number of EPDs by the number of products and by the number of country. So the second point is about LCA for products. They are statics. So the question would be, why not to make dynamic LCAs? That would favor bio-based products because then there would be temporalization and bioenergenic carbon would be taken in account. So that would favor bio-based products. The third point is about land use. The land use indicator is negative for wood regarding to the risks of deforestation, which is not real in Europe. In Europe, forestry is a science, and a large part of European forests are well managed with the PFC or FSC certifications. And so the idea would be to apply a different calculation or to make ICV for European wood. So that would get better results in the LCAs for wood. So then 3 solutions would be the uniformity of EPDs in Europe, to make LCAs dynamic, and to modify the land use indicator. Then a second barrier about environmental is, for us, the increase in primary forests. There is a current ecological or even ideological mode. And we see there a lack of awareness of European forestry and quality and biodiversity, which is quite good in Europe. And we see that there could be a huge problem to come if there is an increase of need of bio-based materials like wood. It faces the lack of raw material if the primary forest extends. So for us, it's quite dangerous to extend the primary forest, even if the idea is very good at the first point. We are also seeing a societal challenge, which is about citizens and authorities who are afraid to build with wood or bio-based materials because they don't know the materials. And for us, that would be nice to modify the cultural background by building public spaces in wood or bio-based materials to give confidence in these materials. To end the economic dimension, the first 2 points we've been talking about them already. That's to arm a more harmony of standards regarding LCAs and EPDs, to work on fire legislation. But it's also important for us to stop thinking of wood as concrete, because they are really different materials. They have different techniques, different impacts, and of course, different prices. And the fourth point is more global regarding the wood sector, but Europe should limit wood export blocks out of European Union. It should permit only to export timber that has been processed in Europe. And that's interesting, but that should give more value to Europe. And that would also permit to keep jobs and the know-how, because that is what, for example, Asian countries are doing for now more than 20 years. And that's quite important for us, not to leave all the logs going out of Europe. This is the end. I thank you for your attention.
Thank you, Nathalie, for your very interesting presentation. I would now like to give the floor to our second speaker, which is Raimundo da Costa del Col, from Way Thistleton Architects. Will also give his inputs on CLT.
Hello, I hope you can hear me and
Yes.
see my screen. Let's see whether the presentation mode works now. Oh, my camera doesn't seem to be working, but that's strange. Let's see whether I can sort it out. Otherwise, I might talk over and embarrassing. Sorry about that. You might not be able to see me, but I hope you can hear me. Yeah?
Yep, we can hear
Yes,
you.
we can hear you.
Yes.
Share your screen. Okay, good. Well, I will start. Otherwise, we spend time just trying to make a camera work, which is not really worth. But anyway, nice to meet you all. I think I've choose the wrong presentation. Just 1 second. The wrong screen, actually. Stop sharing and let's share the right one. Seems like a slapstick comedy. Apologies for this. You might see that I'm not really familiar with Zoom. I usually use other means, but we will get there in a second. Sorry about this. Yes. Okay, this should be working now. Good morning, everyone, officially now. So I represent Way Thistleton Architects. We are an architect's office based in London, which has been building in mass timber for over 25 years now. we have worked on buildings of different sizes and different typologies, like office buildings, which are the type of building which we mostly work on lately. Industrial buildings or industrial facilities, like the example which I'm just showing you here, a large building set in the midst of England, and also pavilions, like the Multiply pavilions, which have helped us to show the potential for engineered timber and also to make the case for biomaterials in many different exhibitions and in many different contexts. So since we are based in England, I thought to give you an introduction to what the main policies are in the UK with regards to timber. We have currently three main policies which focus, or not really focus, but which have timber as a main subject, I would say. The first one is the net zero strategy, which provides basically or describes how the UK will progress in the next 20 to 30 years to achieve the 2050 targets, focusing on the use of timber. The second policy, which I think is really interesting to focus on for us, is the timber in construction innovation, or the timber in construction roadmap, which has set some priorities with regards to the areas which we should be focusing on over the next few years to make sure that timber in construction becomes one of the mainstream materials. The reason why I think that it is interesting to bring this policy on your radar is because through even just reading through the title of those priority themes, we can see what the main barriers are and what the government, the UK government, thinks are the areas which we should apply our studies on in order to make a clearer case for the use of timber. So there is a need to improve data on timber and whole life carbon, so the carbon aspect, so the sustainability aspect of the material. There's an increase of skill and capacity and competency within the industry, which needs to be, which is felt to be needed in the UK timber value chain. An increase of sustainable supply of timber, so we are trying also to have homegrown timber. As you can see, the area of covered forest to the left of the slide, and the production, the UK production is not huge, but this is an attempt which we are actually undertaking. And there are two areas in point number 5, two areas of huge concern, I would say, which need to be addressed, which have to do with fire and durability. Technical problems, I would say, which can be overcome, as you will see later in my presentation, but they are perceived as the key problems with this material. The last thing which I would say is that the increased collaboration with insurers and lenders, so purely financial aspect of this is quite important. And some really interesting documents have been produced in the last year to enhance this communication and to make the case for timber. Now, from our point of view, when it comes to environmental aspects of timber, we are very much aware that we are talking about substitution of material, best material in the best area of use. And this is what we're trying to do, not only with our building, but with multiple documents which we are sharing constantly and parallelly to the buildings which we build, where we explain the reason why timber should be used in certain areas of the building. Let's talk about superstructure and certain specific building types. Because we think that this communication needs to be very clear and needs to be transparent, not only towards our clients, but generally speaking to the general public. There are a certain number of problems that from the point of view of the perception of timber, and those problems are, I would say, can be seen in every single type of society, meaning this is a research which we have undertaken in Italy a couple of years ago, and those are the initial results with regards to the timber perception. But many of the key phrases which you read here could be used also to describe what the take on timber is of the common European user, or would say potential stakeholders. So this is why I wanted to bring this on the table and show you what the outcome was of that research, knowing that you can be able to access the in-depth research if you go to the Timber Perception Lab website and download our report, which is explaining a bit the sort of research which you have undertaken. Not only problems but solutions, and I won't go in depth on this, but I think there are the main solution is to be very clear in the communication to the wider public about what the advantages and disadvantages are, and what the technical solutions are to the main problems which we have. A brief focus on some preconceptions to complete our description of a very brief description of the financial aspects of timber. Those preconceptions are, I would say, shared by most of the traditional construction industry. The common perception is that timber building is complex and that it is a new technology, steel, which doesn't have a huge track record, and that there's not enough competition in the industry in order to get really good prices for the building. But we think that those financial preconceptions go hand in hand with the wider ones about fire and acoustics, which are not only shared, fire durability and acoustics, I would say, which are not only shared by the common people, but also by industry representatives. There are also, on the other hand, many answers which we could give to almost all of those preconceptions, and very clear direct advantages with regards to the use of timber, which we have tried in each one of our projects to highlight and measure, because this is the key thing, measure with hard facts and numbers in order to show what those advantages can bring to whoever wants to invest in timber. I'm trying with this slide just to go a bit more in depth with regards to the financial advantages of building in timber. And I would say that most of them can be directly seen and can be demonstrated on a building by building case. Some of them are potential. I'm talking about the tax credits, but our perception is that this is something which is to come in the next few years. And I would say this is it for the moment from my side, and I hope the presentation was insightful from a few points of view. Thank you for your attention.
Thank you, Ray, for the presentation. And then I would like to give the floor to our last speaker, which is Felix Muscha from Haslager.
Sorry, Toby, I just want to kindly remind to our pitchers to please keep it in 5 minutes, because otherwise we will have no space for also the others. So please, we kindly remind you to be shrinked a bit. Consider that all your presentations will be later on shared with all the participants, so people will have time also to go through them.
I will try. Hello from my side, ladies and gentlemen. I'm delighted to speak to you today as part of the SASTRAC project workshop series. Sustainability is currently a much discussed topic, especially with regard to the construction industry. In my keynote speech, I would like, therefore, to give you a brief overview and hope over the next few minutes I will be able to give you food for thought on the one hand and familiarize you with the potential of cross-laminated timber on the other. By the way of introduction, I would like to briefly explain you who you are dealing with and above all which company you are dealing with. My name is Felix Mucha and I'm an innovation manager at the Haslacher Group. We are a global, active, family-run company in the field of modern timber construction. We see quality and innovation as central elements in order to be able to offer intelligent, integrated solutions, true to our motto, from wood to wonders. If you analyze the results of recently published UN studies, a shocking results emerges for the construction sector. The industry is responsible for 38% of global CO2 emissions. The cement production alone accounts for around 8% of the global emissions. You don't need to be an expert to interpret these figures, but one thing is certain, there's a lot of catching up to do. But I can show you a way to achieve a turnaround. It is something that the way that we see every day, it's renewable and stores carbon. Wood sounds simple, and it is too. In order to avert the climate crisis, it is imperative to rely more on the building material in the future and to develop strategies to increase the use of this material. Active forest management contributes to carbon sequestration. In managed forests, carbon timber harvesting is diverse from unmanaged forests, where the carbon is released again through decay. The long-term storage of carbon in timber structures combined with reuse and recycling prolongs this positive effect. Future buildings should be constructed. However, I would now like to take a brief excursus with you on the subject of cross-laminated timber. Let me start with a few impressive figures to illustrate how topical and future-proof it is. In 2020, the CLT production in the DACH region, including Italy and the Czech Republic, the CLT production exceeded the 1 million cubic meter mark for the first time. Capacities are growing rapidly and will exceed 2 million cubic meters this year, and the expansions are continuing steadily. Cross-laminated timber is made up of crosswise oriented glued wooden lamellas. So far, however, there has been a failure to harmonize the applicable regulations and standards, which means that this is still necessary to have company-specific structures and specifications certified. However, it is clear that the building material is a high-performance material with precisely defined characteristic values and properties. This makes it clear that the behavior in the installed state can be precisely predetermined, whether in terms of mechanical load-bearing capacity, the moisture resistance, or the fire resistance. Finally, I would like to show you the potential and opportunities that arise from this. With regards to innovations and future viability in particular, I would therefore like to briefly outline a few topics we are currently discussing and inventing. The excellent lamella makes it possible to use different types of wood in the visible area to come away from only having spruce or fir, something like that on the surface. And with this multi-layer structure in the surface lamella, we are able to reduce the we are able to not reduce the mechanical load-bearing capacity. In the future, we are the opinion that the degree of prefabrication will be an essential part of the construction process. On the one hand, cost savings, construction time reductions, but also the quality improvements are striking factors that are a clear commitment to the prefabrication of entire wall modules based on cross-laminated timber. Also, here on the second picture, you can see ready-to-paint surface, which is produced directly in one of our production plants. However, the detachable timber-timber connections to increase recyclability are also a key aspect in strongly promoting sustainability in the buildings construction sector. Yeah, with this point, I want to thank you very much for your attention. I would now like to invite you to ask any open questions. Thank you.
Thank you, Felix, for the presentation. I am not exactly sure, Valentina, how we are with schedule. So I don't know if we want to do the CLT open questions now, or maybe move them, or maybe maybe kind of like a short.
Since we're a little bit late, we will keep this question. So we see the question in the chat. We will start discussing about them in the open discussion. So while the people are starting the interactive discussion, we will respond also to these questions. Or if we will gain some time later on, we will specifically answer to that. But be sure that we will not forget about those questions. So we will do maybe later on in the end. So in the meantime, we can go ahead. So I'm happy to introduce Mariam Rashid, experts from BAM from Germany. So the floor is yours for the second case study, biochar as additive in concrete.
Yes, thank you. I don't know who's sharing. I think
it is still Felix that is sharing his
okay.
screen. Yeah.
Okay. I'll just share over.
Perfect.
Am I sharing now? Yes, right? Okay. Okay. So our second case study for the construction sector is biochar in concrete.
Miriam, you're not in presentation mode.
I'm not?
No, we don't see it presentation mode. Try again, maybe.
Like this? Is it now in presentation mode?
No.
No.
Maybe you have shared, maybe you have two screens, one in presentation and one in not in presentation. Maybe if you share. No?
I'm actually just using the one.
Well, try to share the full screen. I mean, your.
Yeah, I was sharing just the
maybe.
PowerPoint. Okay. Okay, let's try that. Is this now working?
Yeah, perfect.
Okay, perfect. Thank you. Okay, so biochar in concrete. There we go. So biochar is one of 3 products obtained from pyrolyzing biomass or waste biomass. And the 2 other products are syngas and bio-oil. And biochar in itself, it's just a porous material. It's very high in carbon, and it's relatively stable carbon. The longer you pyrolyze it, the more stable carbon you get. The usage of biochar in concrete, whether as a supplementary cementitious material or just as a filler in the concrete to lower the GWP of the concrete, has been explored a lot in recent years. And the value chain looks more or less like this. So you have the biomass, you pyrolyze it, then you get the biochar as an intermediate product. You mix it with your normal concrete composition materials, and then you get the biochar concrete composites, and then you can use it normally as you would use concrete. And in the last years, we've already been seeing the first products and projects that are commercially on the market for biochar concrete composites. And some of companies producing such biochar concrete composites are Carstor, which are here with us today, Trinity Biocarbon as well, which are also here with us, Ecoloct and Carbonstead are here in Germany, Clark in Switzerland, and Biocrete in the Scandinavian countries. I'm not sure which one. Biochar in general as a market, just separate from concrete, has been growing a lot in the last years. As of last year, we had 171 pyrolysis plants in Europe. Most of them are pyrolyzing wood, but as I said, you can pyrolyze in general any other kind of biomass. or waste biomass. And it has been growing, and it is forecasted to grow this year to 220 installations. So it has been growing steadily, even during the pandemic. It grew steadily. So it's looking good for that market in Europe. As for the stakeholders, we have the conventional stakeholders we have in any other value chain. We have the industry, which includes all the financial institutes, all the companies producing biochar, also all the companies buying biochar. It's not just concrete companies. You also have farmers, you have fertilizers, you have a lot of applications for biochar. So you have all these businesses buying it. You have industry associations like IBI and EBI. This is the European Biochar Industry Consortium. You also have such associations on a more regional level. So there's ICHAR for Italy and so on. You also have in the industry people trading carbon emission certificates from biochar, because carbon removal through biochar is possible and recognized by the IPCC. So you have platforms like Puro Earth that also sell carbon certificates from biochar. And government, we have the conventional government actors, we have the policymakers, standardization committees, and also supranational organizations like the UN and the OECD. In academia, we have research institutes. Those also include labs, like, for example, Eurofins. Eurofins for the EBI, they certify the biochar. So you have all of these research institutes. You have also, I come from BAM, and this is the Federal Institute for Material Usage and Testing in Germany. And we also research a lot the usage of biochar in concrete. So I think it's generally a heavily researched topic. And you have, of course, the incubators for the startups and so on and so forth. Toby has already mentioned some of the policies relevant for the construction sector. They also apply for the use case of biochar and concrete, of course. So we have the CPR, which is the Construction Product Regulation, which ensures just the safety, health, and environmental protection and sustainability of construction products. Here we have extra because, as I said, biochar carbon removal is recognized. So another policy that is relevant for this case study is the ETS, which is the emission trading system of the EU. And we also have the CRCF, which is the carbon removal certification framework. It is still being developed, so it's not a and it's not a regulation also, it's just a framework. But it will aim to establish a transparent EU-wide system for certifying carbon removals and trading these carbon certificates. Other more general policies that are, of course, relevant are the EU Green Deal and the taxonomy for sustainable activities. There's a lot of indicators, of course, to generally observe this case study. I mean, for concrete alone, we would have a lot, and also for biochar separately, we would have a lot. So combined in general, there's a lot of indicators to measure the sustainability performance of this product. But here we have the most important ones, I would say. So environmental, we have things like the carbon content derived from renewable raw materials, or, as I said, because in Europe, most pyrolyzers use wood as an input material. So we have the share of forest certified for sustainable management, where all this wood is coming from. When you pyrolyze biomass, you usually get PAHs. Those are polycyclic aromatic hydrocarbons, and those are toxic. So also the percentage of PAH in the biochar is important to track. The percentage of materials derived from recycling or recovery from biomass waste, as I said, you don't need to use new wood. You can also use waste. And yeah, the other two products that you get from a pyrolysis are also syngas and bio-oil or biofuels. So also the percentage of biofuels that you produce as a co-product, which also you can sell to energy consumers. The greenhouse gas emissions and the global warming potential of the product at the end is also important to track. And as for the social indicators that are more important for this case study here, we have the presence of formal policy concerning health and safety of all workers along the whole supply chain, and the number of innovative social products that positively impact the local community. And I would say that's it from my side. And then we can move on to our presenters. First, we have Hugh McLaughlin from Trinity Biocarbon. He's the CTO of the company. And I would stop sharing, and then Hugh, you can start sharing.
I'm hopefully people can hear me and
Yes.
perhaps see me. I'm telling this to start from the beginning, and away we go. Thank you for this opportunity. I will note right up front, I am located outside of Boston, Massachusetts. Trinity Biocarbon is located in Cairo, Egypt. And as a result, we have relatively little interaction at this point with the direct EU community. So this is a point at which I elected, because I am very much a biochar technologist, to focus on some of the underlying science of biochar and some of the considerations when it comes to integrating it into concrete, which is such an enormously used material. 8% of global emissions just revealed are attributed to just the production of the cement that gets put into concrete. So it's a great opportunity, but there are some technical issues that I think I'd like to just point out, and they shouldn't be preventative. They should be enabling, in the sense that you need to think about these things and address them. So this is our sort of mandate. I think biochar is becoming, people are becoming aware of it. It's not it's a new material. The word biochar is probably less than 25 years old. So all of a sudden, and it's not charcoal. So that's the thing. Charcoal is a fuel. Biochar is a solid material with discrete properties and potentials. So this is an important underlying point. Trinity started the biochar Pursue track, and we will be probably in production at full capacity of our initial plant in 2025, which is 10 years after the company or the family office started thinking about this. Now, this is a unique situation in that the family office is a family that has the resources to capitalize this plant. So you've completely eliminated any delays associated with bankers and investors and things like that. And that's can be the better part of this timeline. But in addition to having the capital going in, we have a PhD program being executed in the middle of it to convince the family office that this is a good way to go. In other words, they wanted to do something with biomass. They arrived at biochar as the choice. And a lot of that is driven because of the local circumstances around Cairo. It has a very large farming community immediately up the Nile. So they have biomass production. They also have crops to go back and replenish. In addition, in 2020, they established a pilot plant. They've spent, and we'll see a quick picture of that. And then by 2022, we started going down the road to actual design and construction of a full-scale facility. Not a small undertaking, and the preceding efforts up through 2022 were all decision-making efforts, not capital investment type things. This is the pilot plant, the R&D facility to actually test out the materials. They have invested of their own money, and I admire this family. I'm just an outside technical person. $500,000 US, €500,000 euros over the years, and probably a staff of 4 or 5 that entire time to just study the science for themselves. Very necessary to do your own homework. And this is a few pictures of how our plant is coming along. It's a very large facility. It's a world scale facility, but it is also going to service a relatively small geographic area. And now I want to just point out a couple of the constraints and considerations and opportunities that exist for biochar as an additive in concrete. Concrete as a material is an energy pig. So maybe that's not politically correct, but it is an incredibly energy intensive material, and there's really no way to remove that energy input to make concrete from scratch. You can recycle concrete to a limited extent, but you cannot reconstruct it at the chemical level where it cures again without putting the energy back in again. When it comes to biochar, I want to note it is not a homogeneous material. It's not homogeneous on any scale, even the molecular scale. But this is a real consideration when it comes to a supply chain. This is a minority additive going into concrete. If that minority component destroys the properties of the concrete, you've lost everything. The building is no longer going to be acceptable. It is undeniably carbon negative. It is low density. That is helpful in concrete because as you build up, weight becomes very expensive, and therefore to lower the density of the concrete is helpful. But it is quite friable, which means it crushes, it breaks down. Think potato chips. Potato chips are friable, and that's why the bottom of the bag ends up with little potato chips. But if you grind it to a small scale, it actually becomes very, very structural. It becomes carbon nanotubes, and that is a very strong material. Then the issue of binding all this number of particles to the cement needs to be guaranteed or worked out, and that's an area of research. And it can be a challenge because of the fact that there's heterogeneity, so there's localized differences in how the binding is. The advantage is biochar is a wonderful carrier of water and chemicals, and these are part of the ingredients that go into concrete. So now we have a separate carrier for the water that we can pre-dose the water and mix it in, and it'll actually affect the cure of the concrete and get improvements of the cure. Because while technical people probably, or most people don't know this, the cure of concrete is how it goes from being that slurry that gets made up on site to then slowly over time forming the hard solid material with strength. And the slower that cure is, the better the strength is. Bottom line, biochar is a reliable material that needs to be engineered into many carbon positive materials. So it can go into plastics, it can go into concrete, it can go into anything. One of the interesting aspects about biochar is every one of its potential uses, the market is essentially infinite around the world. So when you think about concrete, you think about soil, these are not, when you think about displacing or enhancing the efficiency of fertilizers, these are astonishingly large markets. When it comes to actual implementation, it is very much a business to business relationship. I tell most of my consulting clients, I do that on the side, go find a concrete partner, a cement partner, and work out how the two of you are going to put this together. Because we're a minority component in your larger material, and we cannot affect, we have to improve its performance because we're probably going to be a more expensive additive than aggregates and other things. And the suppliers need to evaluate the supplies for consistency, because if the biochar is bouncing around, and why does it change? Because the input material is a natural material and it changes seasonally. Therefore, you've got to watch out that you are correcting for that change during the production of the biochar. Having said that, concrete is so sort of omnipresent in the construction world that there are a lot of non-structural or non-demanding applications that biochar can be quite straight, easily introduced into and not introduce a lot of performance risk. The other consideration is concrete and biochar are very regional markets. So it's going to be a situation where, back to a business-to-business relationship, the local concrete producer and distributor needs to work with the local biochar producer and distributor to then cut down on the transportation distances, which are typically fossil fuel driven. The other big advantage, and I think people that talk about policy can speculate on this, that concrete is also tested as it is implemented. So you have data created on each of the concrete pours, or you can get it, that creates the ability to defend that the material's is performing. And that is my talk, and I look forward to questions, and I'll be around.
Thank you so much, Hugh. Next, we have Thorsten Grönewald, the CEO from Carstar Con. If you could share your screen as well.
Good morning. My name is Patrick Olschowka. I'm speaking for Thorsten Grönewald for the Carstar Con Technology.
Okay, cool.
So I would share my screen.
Mhm.
One moment, please.
Go ahead.
I need to unshare somehow.
Oh, yeah.
You actually don't need to. You can share
Oh,
over
good.
you,
Steal
but
Away it goes. Thank you.
You can see the presentation and hear me? Hello?
We
um,
still see the
we're
presentation
still
from
seeing.
you. So maybe you, if you can stop sharing, it's easier
It
for
says new
next-
share, and I'm trying to do that, but it looks like it wants my new share, and I don't want to do that. So the way you do this is I leave, I stop share. All right, I
Ah.
disappeared.
Okay, Patrick. Yes, there we go. We can see your
Oh,
screen.
okay. So I think it was a nice explanation to the topic biochar in concrete from McLaughlin. So I can start with our topic. It's the same. It's biochar in concrete and or technical carbon. So we think that is a key technology to develop climate positive construction materials. And oh, I can wait a minute. So yeah, and in the relation and responsibility of a construction industry, and due to the increasing growth, we have also a great potential to reduce the impact of the global emission. So in this fact, we have a strong focus of the footprint of construction materials, especially the applications of cement-based materials like concrete and mortar. So we try to reduce this footprint with innovation and intelligent and good solutions. So the Castlecon use already a biomass pyrolysis for a biochar carbon removal as a advanced negative emission technology. So we think that is a long-term storage solution, and this is why the increasing of the focus of biochar or technical carbon in industrial application, because of the possibility to build up carbon sinks and significant scaling potentials. I think our technology is based on this technical carbon, and we did some modification steps and create an additive for use in concrete and asphalt. So we have a CE certificate and yeah, for standard concretes, and our environment product declaration is almost finished. So by using the additive in different and a lot of samples, we found out that we are able to improve some materials properties like comprehensive strength, water impact of the surface of concrete, and a perfect internal curing to prevent cracks and some stuff. So at the same time, we can reduce the CO2 amount and by using less cement in the concrete mixtures and including a high amount of carbon storage. We have at the moment a lot of projects we did already. So the next pictures of this are our used material. Yeah. So this is the office building of the energy plant in Dornbirn in Austria. We realized the base plates, ceiling, stairs in a concrete amount of 80 cubic meters. And the sequestered CO2 amount is by 6.3 metric tons. Also, we make in Austria a technical building for the Austrian Rail Transport Company. So it's the same realized parts, the base plates, walls, and ceilings in an amount of 101 cubic meters. And our biggest project was the industrial plant in Riedlingsdorf in Austria. So we realized a whole amount of 2,730 cubic meters and sequestered about 290 metric tons of CO2. Yeah, so our questions and biggest challenges in the near future are to find ways which are in line with the requirements from the European standards, and the construction product regulation. So we need, according to these regulations, harmonized rules on how to express the performance of construction products. We think to speeding up the decarbonization, we need to switch to more performance-based standards to take a step forward in neutral technologies. So I think I hope it was interesting for you, and if you have questions, let's stay in contact. Thank you very much.
Thank you so much, Patrick. Valentina, should I head over to you? Or back to
Yes,
Toby?
thank you. Thank you very much, Mariam. Thank you very much to all our teachers. Very interesting presentation. So we will move to the next case study, and later on I see that in the chat are going on some discussions, so we will really catch up on those discussions. I will leave the floor again to Toby then for the last case study. So the hemp insulation. Toby, please go ahead.
Yes, I'll do it very quickly so that we can have the pitches afterwards. I'll share my screen. Can you guys see my screen or sharing?
No, we don't see it yet. Yes, now we see it, not in presentation mode. And now it's in presentation mode.
All right, so let's do it very quickly because the people who will present after me will probably say more interesting things anyway. But let's say the general description of the case study, it's like hemp insulation, maybe with a focus more on the wool material, but we'll also have some people talk about hempcrete or hemp concrete. So the feedstock starts, of course, with hemp stalks, which then need to be further processed. So there's two main materials maybe from hemp, which is the fibers and the woody core, which both can be used to make insulation materials. For the wool and met materials, we mainly use the fibers together with maybe some binders to create mats, but we can also use these woody cores from the plant to mix it together with lime to create a sort of hemp concrete, which can also be used as an insulation material. The final product, of course, is insulation that at the end of life can either be like mechanically recycled, but since it's a bio-based material and depending on the additives that are used in the recycling product, it can still remain fully bio-based and therefore also be, for example, decomposed. A quick baseline market. So hemp can be used as a, let's say, direct substitute for already existing insulation materials. But at the moment, these, as you can see here in the graph, the bio-based or the other material are still not very much represented within the total market of bio-based materials. So there is still a lot of room for improvement. Something that hemp insulation, but in general bio-based insulations can do, however, is that they have the same thermal and acoustic performances, but they also have this additional capacity of moisture regulation, which can be a big plus point for bio-based insulation materials. Then a quick overview of all the different stakeholders. Here at the center, again, the bioeconomy supply chain, which starts with hemp cultivation, and then all the different stakeholders who are involved within the processing, manufacturing, and implementing hemp and hemp fiber insulation. And also, of course, there's also input from government, research and academia, industries, both for use that would buy hemp insulation, but also sell it. And also, of course, the citizens and people who also have input. A quick overview of the policies. Some of these have already indeed been mentioned in the previous presentations. Maybe here one to highlight is maybe the Energy Performance of Building Directive. As you know, it's a policy that aims to really increase the energy efficiency of buildings. But with bio-based installations, not only can we do that, but we can also help reduce the embodied energies of the materials that we use. So this is where bio-based materials can have this additional function. Then some important indicators that we have identified with a focus both again on global warming, the reduction of greenhouse gases, as well as the storing of carbon. And of course, since we are talking about let's say an agricultural product, there is maybe also a mention of the land that we use for the production of hemp. Then on an economic scale, on an economical scale, the rate of recycling as well as the potential biomass potential are highlighted. And also, just production, both in terms of total raw material as well as agricultural biomass and the cost of production. And the social is a bit similar as with the CLT. So this was very, very fast. So I would now like to give the floor to Paolo Ranchetti, who...
Yes, he's the director of Tecnocanapa
Exactly.
product line by Senini SRL, and introducing sustainable innovation in the construction sector, and is also a member of Federcanapa, the Italian hemp federation. So Paolo, the floor is yours.
Yes, coming up. Perfect. Can you see my presentation?
Yes.
Yes.
Perfect. Hello, everyone. So I am in charge of the Tecnocanapa product range within a much larger industry, which is Senini. Senini is based in the north of Italy, and it is a major player in the cement products, like floors, like blocks, like curbs for the streets. There are 5 plants within the industrial location. One of them is totally dedicated to hempcrete products. What is hempcrete? Hempcrete is a mix of the wooden core of the hemp plant, water, lime, and in our case, probiotics, which is a patented mix that we came up with in 2015. Hempcrete products are used for the envelope of new and existing buildings. So it is both a construction material as well as an insulating material. We manufacture 3 major hempcrete products. One of them is the hemp block, which is industrial manufactured by using one of the 5 plants, which was an old plant that was built for making cement products, and we adapted it, upgraded it in order to produce the hemp blocks. As you can see, is a fully automated production line, which allows us to produce the hemp blocks in a very competitive way. Here you can see an example of the hemp blocks used as the envelope of a new built 4-star hotel in a ski resort in the north of Italy. 40 centimeter thick hemp block is the only material that makes the envelope of this concrete frame building. Just for you to know, hempcrete is a non-load bearing material, so it always goes in connection with a frame, a structural frame, which can be made of cement or timber or steel. Another product that we make is low density hempcrete. We supply it ready to be used in big bags for the insulation of the roof and the floor. So ideally, a hemp construction, new or existing, can have hempcrete on all the different parts of the envelope. So the floor, the roof, and the walls, in order to make it very, very efficient. Another product that we produce and supply is low density hempcrete, which is spray applied. So we developed specific machines for spray applying this product for mainly for walls, new walls, or insulation of existing walls. This is another example of a spray applied hempcrete in Sweden, where we trained a local community. It's a yoga community of an Indian guru who basically started self-building new construction like the one you see, with a timber frame and with sprayed applied hempcrete by using our machine and our patented mix. Finally, the third major product is a plaster, is a thermal plaster, which again is made with hemp and lime and probiotics. And in this case, we use finer hemp. So I now would like to go through a few, points in terms of policy dimensions. So we started as pioneers in Italy with a startup company in 2011. The hempcrete market value was 0, so there were no hempcrete construction in Italy at the time. So fortunately, we didn't encounter any major barriers in terms of regulations. We just had to follow the construction materials regulations. So we basically certified all our products and application according to the existing regulation. And so we were able to immediately start the business. Unfortunately, so far there are still no incentives for plant-based materials, and of course for hempcrete products. So we basically compete with mineral and insulation and synthetic materials with no support. So it's you can imagine how difficult it is. But it's a challenge that we are happy to fight. Hempcrete at the moment cannot be CE marked because there is no European harmonized standards on these innovative products. However, we are working at national and European level in order to get CE marking. And in the meanwhile, we are also applying for ETA, which is a European technical approval on a specific products, which is recognized as CE marking for a specific manufacturer and a specific product. Another issue that we encountered during 2020 and 2022, in Italy, we had an incentive scheme for the retrofitting the energy efficiency of existing buildings, which gave back 100%, 110% of the investment to private to anyone willing to improve the energy efficiency of existing buildings. However, natural materials were not even listed in the minimum environmental criteria. So basically the requirements for an insulating material to be recognized, which of course did not really help in promoting our materials, or in general natural materials. Another issue that we are encountering in terms of policy is that hempcrete shows a specific hygrothermal behavior that is not fully recognized by the official ways of assessing thermal performance for insulating materials. So just to make it simple, the way to compare insulating material is the thermal conductivity test, which is a test made for materials, mineral materials, or synthetic materials that are non-dynamic, are totally stable. However, hempcrete is a dynamic material which shows better performances than the other conventional materials that is not measured by this specific test. What does this mean? It means that we follow the conventional rules, so we apply specific thicknesses of hempcrete, but at the end of the project, at the end of the day, the performance that we supply is much higher than the theoretical one. And finally, there are still many uncertainties in the industrial hemp supply chain, mainly in Italy, because of continuously changing regulations on cannabinoids like CBD. So when we want to look at the environmental dimension, as I just said, there is an extreme performance of hempcrete in terms of thermal insulation in both summer and winters, which provides top living comfort thanks to the hygrothermal regulations. So there are no current conventional materials that can provide the very same performance. It's based on the hemp chives, the wooden core of the hemp plant. So it's a totally renewable raw material. You can grow it, you can source it every year from the soil. So it's a very interesting concept, which really helps in making hempcrete carbon negative. We now have an environmental product declaration that allows us to count the negative CO2 that we can store in every cubic meter of products. As you can see, it can go from 44 to 105 kilos of CO2 per cubic meter. That means every single project, whether new or existing, retrofitting of existing building, we can end up storing tons of CO2 in each project. So this is, again, another feature that no building materials have at the moment on the market. During the first few years when we started as pioneers, we really suffered the cannabis stigma, and the major joke that we kept hearing was, yes, but what if the house takes fire, goes fire, so people will be high, which is unfortunately a stupid way of describing this material, which the toxic part of the cannabis is the flower and not the wooden core. But anyway, lack of awareness at the beginning forced people to joke on us, but now the situation totally changed, and we see a very positive outlook for the next few years, because there are very few alternatives to insulating and building materials that can compete with hempcrete. Finally, in terms of economic dimensions, we learned on our own skin that the building sector has a very long cycle of innovation, which is, as you can see, 8-9 years compared to the information technology, information and communication technology sector, which is just 3-4 months. The cycle of innovation, the meaning of the cycle of innovation, is the time that a product takes or a technology takes to be known and widespread and used on a large scale.
Paolo, can you please speed up this last slide,
yes.
because we are
finally.
Thanks.
This is the last slide. So we went from a garage startup in 2011 to, as you saw, to an industrial scale operation. From small retrofit jobs to multi-story real estate developments. We saw a steady growth in market awareness from all players in the market, and we are now seeing a spike in demand, which very likely indicate the beginning of an exponential growth. Finally, we see demand growing from a foreign country. We export in the UK, Sweden, Ireland, so both Europe as well as overseas. And the final and unfortunately last problem that we have, we are totally dependent on import of the hemp sheave from France, because at the moment there are very few industrial hemp processing facilities and none in Italy. Thank you very much.
Many thanks, Paolo. Back to Toby.
Yeah, thank you very much, Paolo. Then I will introduce our last speaker, which is Bart de Haze from Isohemp. The floor is yours, Bart.
Can anybody hear me? Anyone hear me?
Yes. Yeah, can you hear you?
I'll try to share Oh, la, la, la. As you, I'm not so good in. I have a lot of work, so I have a lot of things opened. I'm trying to find it here. Can you see it now? No. Hello?
No, we cannot see it. I suggest you to share the entire screen just to avoid problems.
You suggest I should?
It's coming.
Something is coming.
Okay. But I'm so happy I can be the last one because I've heard a lot of things I wanted to say. And I also noted some things that haven't been mentioned yet. I would like to thank Nathalie Lebrun, who made a nice summary of what CLT can become. I also heard Rai and Felix, Mariam, and the other ones. But I was really interested in what Paolo had to say because we are similar companies. We are a company based in Belgium with the same history, but I'm not going to herhalen to repeat all the things they said about legislation and the difficulties we had to come into the market and to get our necessary ETA or EPD things. Some things I would just like to add so I can stay in my 5 minutes, and I will surely stay in my 5 minutes, is we didn't talk about the changing climate and the advantages of natural materials that can be that could be a solution for some climate changes. Let's say for insulation is now specifically tested for winter, but we should try and get the phase shift into the legislation. That's one thing I had. And what about reuse? What about how can we develop systems instead of materials? I would say if at the end of life of a prefabricated wall or roof, whatever, how should we go on between concrete? Because I was really interested in the biochar. I don't know much about it, but I think there might be a solution in combining that with, for instance, natural materials. So I would just, because everything I had to say, and still my presentation is not here.
So Bart, if you don't mind, I can share for you. Is it okay for you? So
yeah, but it mainly says what Paolo and what Nathalie have said, that we encounter some problems on a legislation level. We also the development, the switch is going on towards natural materials, which is, I think, very, very positive. But I also think that the key to move forward and to move fast would be to get some collaboration between the concrete industry and the natural industry and find some solutions which are not material based but system based. And I've seen some participants in the webinar that I think will agree with me. So that's all.
Good.
Short,
thank you, Bart.
You can all. I also see maybe just one more thing. We haven't spoken about other materials which outside of hemp, which are a very good combination. I'm thinking about, for instance, in Italy, there's a company called Mogu who's in charge of everything that's mycelium, elephant grass, bamboo, maybe willow, should be integrated in the conduct of building for the future.
Thank you very much, Bart. So I think we can move to the interactive discussion. So we will introduce our interactive tool for the interactive discussion, and in the meantime, we will then take the questions that are in the chat. If you have questions also for Bart, Paolo, and for the other features, feel free either to speak or to write them in the chat. So Luis, if you can start sharing the screen, I will share with you the link
No,
to the
he's already
interactive
sharing,
tool.
Luis, but it doesn't work. So maybe,
Ah.
yeah, or maybe Bart, you have to unshare.
Yes.
Can't find it. No, I believe
We still don't see it.
something has gone wrong. No.
It's a little red,
Bart,
little
your
red box
cracked
next to the
system.
sharing that you click. That
But I
unshares.
can't see any I don't have anything left in the sharing. That's the problem.
No, I mean, I'm seeing Luis's screen already, so
Oh, you see it?
yeah.
Oh,
At
okay.
the
Just a
top
quick,
of the Zoom window, you can choose which screen you're watching. You can either check meeting and there's shared screens, so there you can choose the one from Luis. Ah, also.
Is it gone? Yeah. Okay.
Already? Okay, perfect. Okay, so I'm going to explain very quick. Miro, probably a lot of you already used it. This is an interactive tool where you can interact with, and you can zoom in and zoom out with your mouse, with the wheel of the mouse, or use the zoom in the bottom right corner of the screen. Okay. With the right button, you can move the screen, and you can pick up the sticky notes that are here. Then Valentina is going to explain what are there for. And you can move them in the area, double click, and write your content. Okay?
Okay.
Yeah, I think it's all. Valentina.
Yeah, thanks, Luis, for the quick introduction. So what we are asking to you here, as you saw from the presentation of our features, so we already collected some challenges related mainly to 3 dimensions. So the policy dimension, the environmental and social dimensions that here in the Miro we call sustainability dimension in general, and the economic dimension or market dimension. As you can see, we have all the 3 case studies we already went through during the workshop. So we are asking you to add your specific challenges that are different maybe from the one collected from our experts today. But also what we want to know from you is that if you have specific good practices that you already implemented to overcome some of these challenges, or recommendations to overcome such challenges. So basically you will have the 3 different post-its. One in red is to collect your challenges. So here we already reported the one presented by our teachers today. In green, you will have the ones to collect good practices and recommendations from your specific experience, also referring to specific challenges. And in blue, you have the policy context, so in which policy context you operate. Note that all these post-its can be specific for the specific case studies, or you have a place also for the whole sector. So if you are working in the construction, but not specifically in one of these 3 case studies, you can also give your contributions in the more general sector of construction and in your specific value chain. So in the meantime that you go through the Miro, I see that already some people are in. You will find the link in the chat. I don't know if in the meantime we want to take some questions. So I saw that at the beginning there was a question for Natalie, but Natalie already also answered writing in the chat. So thank you, Natalie. I don't know if you want to add something in respect to the questions, or
Okay.
Toby,
Yes,
also there was a
Tatiana that is
question.
raising her hand. Tatiana.
Oh, good.
Marina.
Hello.
Hello.
Thank you everyone for fruitful, not yet discussion, but the insights. I'm from Finland, and we are working in a biochar department. So my question would be to you and Patrick. And then you were speaking about biochars. You're referring to biomass, like origin of the sources for production of biochars. And that's my question, what's the primary source in your companies? And as a supplement to this question, are you targeting the secondary material like sludges other waste materials. Thank you.
You asked me from Clustercon Technology, yeah, it's right?
Yes, you
Yeah.
and also
So
Hugh.
our primary source is timber. Yeah, it's like grinded timber, and it's get pyrolysis in a double stage pyrolysis. So we have a very high temperature, and so we win a lot of energy in form of temperature, or in form of heat, and of gas. So and the rest product is our climate edge. So we modified it the product, and it's working really very fine in the concrete matrix. Yeah. We have a very high carbon content. So I think it's over 90% is pure carbon, and this is this information.
And Trinity?
Hugh McLaughlin will comment that our primary source will be residues from grain production from crops, which are not woody based; they are grass based, and that's because that's the local crops that are produced around Cairo. And the answer is yes. Any material can be made into a biochar, but the variability becomes an issue. And basically, it's the vegetable matter, not the plant matter or the algae, that makes a biochar with good structural properties. So as you can see with Patrick, he's using a very high quality input material, very stable, and it gets a very stable, high quality product out. As you start drifting away from heartwoods and clean, homogeneous materials, you pick up variability and you pick up variations in mechanical properties. So it's very much a sow's ear versus a silk purse trade-off when it comes to biochar. But it is a goat. It will eat anything and produce fixed carbon, and that is a very fine quality.
Yes, just why I ask him, and maybe I will contact you later directly, because here in Finland we are working with pyrolysis of different waste streams. Particularly, we are working recently with textile because of our legislation in Finland. And why I asking? Because a biomass and you're producing the biochar, which could be used in agriculture, not in a construction. And we are asking if we will use another source which will produce the chars, which couldn't be used in agriculture. Will it be even more beneficial for building sector or not? And that's what I tried to understand, but thank you for your comments. It was really valuable.
As an engineer, nothing beats a data point. And these are very simple to obtain. You can do the pyrolysis and test the material, and it scales from there to world class. So I think the answers will be forthcoming, but frankly, it is not possible to predict the properties from the input raw materials and the pyrolysis conditions. It's too variable.
Yeah, thank you very much.
You're welcome.
Okay, so I don't know if in the meantime our experts in the Miro board had already saw some interesting challenges or recommendations, good practices they want to comment on.
There is also the question that was already answered, but maybe it's interesting for everybody about gluing the different layers of wood, and also the question of the coating for fire resistance. So this was already tackled, but I don't know if you want to say a couple of words, the experts, about that. And there are other questions. So is someone tackling this question? I've seen that there is already a question, an answer, but maybe you want to tackle this, Toby, or the experts in laminated, cross-laminated timber.
Yes, just to make everyone understand. So there is this question about the glued layers. So since there is the addition of glue and other substance, it is considered still a circular material regarding the end of life. So Toby, maybe you want to start the discussion here, and then we ask also to our CTL experts if they have other opinions or they would like to share.
So yes, well, when we look at the circularity can still be kept when you look at reuse. I think Felix also mentioned this in his presentation, but if we start looking at designing our buildings as well with the idea of that we can also disassemble them afterwards, then technically, although this is still, there are still some questions regarding regulations and certification of the reuse of materials, but the CLT panel could be reused and reused in a different construction or partially reused or dimensioned. And then of course there is, so the glue technically is of course a permanent connection that still remains, but there is still, let's say, a form of recycling, but it's technically, it is downcycling, where, for example, CLT can still be used for the manufacture of, let's say, chipboard or OSB, so other engineered wood products, but of course the connection between the timber is no longer usable. And then of course wood it's still it's a bio-based material, so even if we at the end of life and we don't really see something that we can do with it and we burn it for energy, we can still use that energy for the production of new CLT. And since the carbon is being stored during the life of the product and we regrow trees, so there's still always a level of circularity when it comes to CLT. And then
Can I add something, Toby? It's Raimondo here.
Absolutely.
I totally agree with what you just said. This is the best case scenario, and the reuse one-to-one of components. And this also is linked to what was mentioned earlier on the system thinking about timber components and timber construction. Ideally, system thinking means that from the conception of a building, what you try to do is to use components which have already in mind, in a way, or have the potential to be reused because they are, in a way, such like in a car, they are part of a system. And so beams, columns, and slabs ideally can be taken apart and reused one-to-one. This is the best case scenario. But if remanufacturing needs to happen, then it needs to be kept ideally to a bare minimum. There are a series of strategies, technically speaking, which can be put in place in order to do that. One of the ones which we use is to try to always make the connections of our buildings accessible, use dry construction rather than wet construction anywhere, and think about what the scenario is for the reuse of components, because this is the biggest deal. Having a sort of financial case for that. This is what we find to be a bit difficult yet, but it's something which even as architects we try to think of when we work on our buildings. The other thing also with regards to the presence of glues, it is actually minimal, the percentage of glues in relation to the mass of the component. We are talking about less than I think 2%, but the key point is that in the worst case scenario, if we have a glulam beam or a CLT component, well, the worst case scenario is that it's incinerated to create energy, but it could be also transformed back in lamellas, the original lamellas which were used ideally to create the timber itself. It's not an easy process, but it is something that could be foreseen, basically. But again, the best case scenario is one-to-one reuse or a minimum amount of remanufacture for the components.
Thank you very much for your answer. I see that for Bart from ISOEMP there is a question in the chat. I don't know if you had the chance, Bart, to see it. So they are asking if you have comments on the mycelium-based composite for building sector and how it can comply with EU regulations. I don't know if you can answer to this question, Bart. If he's still here.
If Bart is not there, maybe may I add something to what was previously said?
Of course.
Right. So about CLT and the use of glue. Right. Well, I think that what is the most important is that we make really long-lasting materials. So the aerosol is more than 100 years, so that's a long time to store carbon as first. And the eco-consumption of the building is very important as well, so that you really have to take in account not only the material but the whole building in order to dismantle it if necessary, and to recycle. But before recycling, it's really the reuse that is important, as Toby said. And recycling is important as well because, for example, in Belgium, I think in Flanders, Unilin say that they really use 5 times the recycling to make panels in order to build furniture. So it's quite interesting. I wanted to add as well that there is now a large research about the quality of glue. Now we see that there is a large research on bio-based glue. So I guess that in a few years, very quickly, I hope, we will get structural glue able to be able to be used in CLT. And I wanted to add as well that regarding Stabilam, we also make nail CLT, in which there is no glue. And we make nail CLT, and we have innovated as well in a CLT in which the nails are also in wood. So that material is 100% wood, and it's very easy to recycle. The point is that economically, it's more expensive than glue CLT, so it has a little bit less success. That's it. But I wanted to emphasize what the design office of Third Whistledown say, that the conception of the building is as much important as the conception of the material. That's it.
Thank you, Natalie. Thank you for your intervention. I saw also in the Miro board question, basically for everyone, I would say, how do termites and other damaging insects for the wood react to hemp and bamboo-based materials? So can you provide your insights to these specific questions?
I can only answer for hemp at the moment. Hempcrete or hemp is often or mainly construction material involving chalk, and all living animals are not so keen on living into chalk. So for hempcrete, it is not an issue. I think for bamboo, it might be, and for the other materials, I think the other experts should be able to answer. But I would like to add something for the mycelium-based composite materials. I think there's a lot of investigation going on, and I think Toby and Reinhard know what I'm talking about here in Belgium, whereas to combine mycelium as a binder, a bio-based binder for some materials, but it complies with the EU regulations, I think is general for all natural materials who are being punished at this moment with the EU regulation in general. Our legislation is still based on rules that have been, let's say, initiated by the big major industry like Unilin and others, and I think that is at this moment the major problem. We have to get into and get a chance to promote natural materials in such as mycelium, of course, in the market. Sorry for my English.
Oh, no worries, it's perfect. Thank you, Bart.
I don't know,
So-
maybe Paolo, do you want to add something with regards to these topics and also to the question of the feedstock availability? Because you mentioned the fact that it's not easy to have local feedstock with regards to hemp. So this is also something that maybe is interesting because all the bio-based, let's say, value chain should be kind of local
Yes.
or at least, yep.
Yes, absolutely. I mean, there is an increasing demand of hemp herds. So that is creating lots of pressure on the agro-industrial supply chain, which is good on one side because it means that hempcrete is growing very quickly, both in Europe and globally. But it also could create problems in terms of material sourcing. We are not there yet because we, of course, sign contracts with industrial suppliers, which on their side prefer to supply larger quantities of hemp chives to industrial players. But that is an issue. Which I hope and I'm sure is going to be solved by the addition of new, plants for processing hemp all over Europe. As far as we are concerned in Italy, actually yesterday I had a meeting with a startup company which is going to start hemp processing in the center of Italy at the end of the year. Another new company is starting to supply hemp chives in north of Italy again at the end of the year. So, demand is growing and at the same time, the supply is following up. So I see it on a positive perspective, not as a problem. Okay.
Can I just add something, Paolo?
Yeah, please.
Please. In Belgium and Holland, we have something called from land to pand, which means we also included the agricultural sector section of the industry. And we grew, I started it 5 years ago when we had approximately 300 hectares in Belgium. This year we already are up to 2,400, and next year the contracts with the agricultural section has been signed, and we are moving up to 4,000 hectares. Is that the correct English word? In Belgium and Holland. So there's a real gain for the agricultural sector because hemp grows in 90 days, grows up to 4 meters, and can be used as an intermediate product. So it means it has all the advantages. The only thing we are trying to do now with the politicians is to add the carbon credits to the agricultures, where it will become a really good business plan for the agricultural sector. So, as Paolo said, it's growing and it's growing fast. I think in 10 years, hemp will be all over the place. If you go to the south of France, you can go for hundreds and hundreds of miles seeing hemp all the time. Already now. Am I correct, Paolo? I see you laugh.
Absolutely, you are.
Okay, so maybe the technical partners have something to highlight because we are about to finish. So I'm asking to our technical colleagues if you find something that you would like to highlight.
I also see, sorry, Susanna, very briefly, a question in the chat also from Paula. Since this was one of the main challenges identified, was the lack of standardization as a problem. And so Paula is asking if certification are going to be developed on European level, which benefits do you see as experts of a standardization development, let's say, if someone wants to add something on this to answer to Paula.
I think we have to take into consideration that Europe is not the same. For instance, the climate is not the same. So if you want to integrate European standardization, we also should take into consideration that Denmark is not the same as Spain, and local way of construction is very often different in different countries. For instance, Belgium is still a polyurethane country, whereas, for instance, the Netherlands have already banished. So I think it's something to consider, but it will take a long time. I think it's better to have a European legislation, but still respect the local laws for some time. It's my opinion at this moment.
Yes,
but we really should collaborate.
And this is also one of the reasons why we are here, to facilitate the exchange, the mutual learning, the exchange of ideas, and then this will take place also in the other two workshops that we still have open on plastics and on textile. You can still register. And if you're interested to share your experience with the SaaStrak experts and to be mentioned as one of our case studies, so if you have something that we didn't consider, you can contact the names that are here in the chat. I will also put them in the chat, so you can copy and paste. And I don't know if our experts would like to add something or to ask something.
No, I think from my side, as was mentioned in the chat, I think the most highlighted barrier or challenge is really the lack of standardization, or maybe even not the lack of standardization, but the standards that we have right now not being lenient enough to accommodate for more innovative projects or products. And I was in a lecture about the green transition of the construction site last week, and it was said that the professor said that the construction sector is one of the most conservative ones, and I think this is generally just something that the construction sector needs, is new standardization, more market-driven ones, more ones that accommodate for innovative solutions, and as Bart said, ones that are harmonized, especially in regards to all the usage of biomass and all the usage of, all the carbon accounting that comes behind it. So we do need a more harmonized framework and more harmonized standards, but they also need to be flexible enough to accommodate for the regional differences, so that it does not preference one or the other region, and also it just accommodates for all the fluctuations that we will see. And generally, just working with biomass, it is an input material that is very not homogeneous, as we have heard today, for example, for biochar. So I think this is, for me, the biggest takeaway, from today's workshop.
We live in a fossil fuel philic world.
Yes.
And regulations and practices all need to be modified, revisited, and incentivized to move away from fossil fuel philic regulations.
Mm-hmm.
Yeah, I have some similar thoughts about it indeed. Like both a mindset change from both people to focus on this transition and on using and implementing sustainable materials and practices. And within the construction industry also, regulations and standards and norms that also focus on this implementation and the use of the wide variety of bio-based materials that we actually have available already right now, and to really focus on how can we implement and which materials suit which solutions the best in which regions, because of course not every solution will work everywhere. but with a good cooperation between all our stakeholders and all the people within the construction sector, I think we can have quite a big impact and really tackle the goals that we have set for ourselves in the future.
Okay, I think we get to the end. We are 6 minutes after. So Vale, maybe we can close here.
Yes, I agree.
Yep.
You already said that if you want to contribute, still you have the email also in the Miro board. We will follow up to you with the presentations, the link to the Miro board and all the materials, the recording. So you will have also the opportunity to go back and check something if you want. Also, the Miro board will be kept open if you want to add something again. And if you're interested in joining also the textile and the plastics workshop that will be held tomorrow and on Friday, I will put here in the chat the link for
I already did it.
For the registration. Okay, great.
Is
So you will...
the presentation, so the page in our website, so you can go and have more information.
And in September, we will soon communicate also the date of the plenary session, where we will give to you as participants back all the results and the outcomes from all these 4 sectorial workshops. And we will also share some results from our project and more results from our research. So I hope to see you there. And thank you very much for your contributions. They were super valuable for us.